This computer. Alrighty. Hello everyone. Welcome to week 2, day 3 of Delta Evening and Weekend. Hopefully you all had a restful Monday. I know the past few days have been a bit intense, but hopefully you guys will have a nice break tomorrow before the long day of Saturday. But unfortunately, today is not a break day. Today is day 3. So hopefully y'all are prepared for that. So before we jump into the new hopefully fun material for today, would anyone like to maybe just take like 30 seconds or a minute and just talk about maybe what you guys learned yesterday, if there were any things that you had problems with, or things that you want to review, or anything like that? Any volunteers?
Yeah, I think Elijah actually put something in the Slack channel to go over the Armstrong challenge. But yesterday we did review setting up classes and doing functions within those classes with Python. So I thought that was pretty interesting, but not 100% on it yet.
Okay, gotcha. Well, don't worry. Today we'll be doing a little bit more of that as well. So hopefully that'll help clear some things up. But thank you for sharing that, Matthew. Anybody else have anything that they had a little bit of trouble with, something else that extra that they wanted to cover today, or anything they wanted to review?
So yeah, I second that. The Armstrong challenge was challenging. And I think for me it was because I did not really understand the input that we were supposed to put in. In JavaScript, the function was empty, didn't have a parameter. So I assumed it was a number and not an array. So I worked on that for a while, and then just based on the test and on the text, I couldn't figure it out. So I was going to suggest if maybe before starting challenges, we can just kind of go over the process of looking at the challenge, reading it, and figure out input, output, either based on test or on the text.
Sure, that sounds like a great idea. So before we'll start off with the Armstrong number challenge, and then after that we'll jump into the new stuff for today. So before we start, I'm going to give a little bit of exposition about the problem, and we'll all like group work through it. But is there anybody who really likes the solution they came up with that would not mind sharing it with the class in maybe 5-ish minutes?
Sure. Austin and I
Okay.
had a pretty nice solution, I thought.
Great. Okay, cool. So, Kasib, I will call on you and Austin in like 3 minutes or so.
Okay.
So, yeah.
Sorry, Austin, I didn't mean to call you out.
No, it's all right. I don't care.
Yeah, okay.
See, when one of you says something, that means I have to call on the whole group automatically because it's not fair to just single one person out. So, all right. So let's go over the Armstrong problem. So let me just pull it up real quick and share my screen. Delta. There we go. All righty. So can you guys see my browser okay? Okay, cool. So this is the Armstrong numbers problem that you guys probably went over yesterday. So the way that I like to break down any sort of programming problem is just going literally from the top down. So, okay, what's the first thing we need to look for? Well, it says an Armstrong number is an n-digit number that is equal to the sum of the nth powers of its digits. And then they give a couple of nice examples, like, how single-digit numbers are all Armstrong numbers, how some numbers like 371 are Armstrong numbers. And then the next thing is to figure out all the Armstrong numbers between 0 and 999. So this is a lot of numbers to go through. But first, does the idea of what an Armstrong number is make sense? Does anyone have any questions about that right now? Okay, cool. So let me switch my share. Let me just make a new file here. And let me share that. Share screen. Okay, so now I should be in VS Code. So I'm not going to pick any language for this. But what we are going to do is, oops, that's the wrong one. Is it this one? Yes. So I'm just going to copy this over into my VS Code. And we're not going to actually code this out. So that is what Kasib will show us in a few minutes. What we are going to do, though, is just think about how we can break this problem down into a little bit of pseudocode and work from there. So what should our first step be when pseudocoding this problem? Where would you guys start with this?
Input and output.
Okay, cool. So input, output, and then I guess we could just say function. So what is our input?
An integer.
Okay. Well, first off, what do we want our function to do?
We want to find all the Armstrong numbers within a range.
Okay, good. So does that necessarily, so there's two ways to approach this, right? One way would be to write a function that the function goes through 0 to 999 and checks all the numbers within it. The second option is to write a function that checks if a number is an Armstrong number or not. And there could be other options for how to tackle this too, that you guys can come up with. But which approach would you guys like to do for the purpose of pseudocoding right now? Any preferences?
Would you mind looking at the test cases really quick? Because with the test cases, it seems to me you have to do one way, unless I'm wrong, like at the spec file.
Yeah, that might be correct. I actually haven't taken a look at this one in a little while, so let's do that. Let's do the Python one, because Python is easier to read. Ooh, interesting. Okay. Yeah, so I mean, in that case, based on what you're saying, it looks like that they just want you to input. Okay, so they didn't really specify the input and output format in the problem itself, which I think is a little bit weird. But that's also why going to the spec file is helpful. So Ozuka, thank you for directing me to that. So going back to what Tiffany was talking about inputs and outputs, we go back here. So based on what the spec file has, the input is just going to be like a list or range of numbers, right? Based on that, at least that's what the spec file suggests. So what goes in our output now?
I think it's an array of all the numbers we find, all the Armstrong numbers.
Perfect. So we'll say list of all the Armstrong numbers from the original list. Okay. So now what the function does is chooses Armstrong numbers. So how do we do that? How would we choose Armstrong numbers?
So the Armstrong numbers is the length of the number, the digits in the number. We have to determine that. And then we have to multiply each digit by that and the length. And then we have to sum them all together.
So figure out how many digits are in the number, take each digit to the power of the digit, and then add them up. And if they add to the original number, it's an Armstrong number. So this is essentially where we would start from pseudocode. Now from here, we'd go into, okay, we might need to add some loops. We need to add in some code that breaks down the digits. We need to find out, how we're going to make the if-else statements work and stuff, but we won't do that now. But this is essentially how we start the pseudocoding process. So we start from like what we're given, what we need to find out, and then what on earth has to happen in the middle in order for this to work. And for the middle part, I'll now turn things over very briefly to Kasib and or Austin to present your guys' solution. So whenever you're ready, feel free to, you should be able to share your screen. So if you want to do that, feel free.
Okay, I will. Thank you. So basically the solution Austin that came with was a nested for loop in that for each number in that range that you generate, you need to first the answer needs to be pushed to an empty array, and that the power is really the length of the number. So to get a length of a number, you need to convert it to a string. And that for each number, you need that total. So you initialize a sum variable before you hit your nested loop. And because we didn't need, I'm sorry, I should go over this num array in order to iterate to those the digits in each number, you also need to convert it to a string again and then split it so it's an array. Because we didn't need the index, we chose to use a for of loop. So now we're iterating in this nested for loop, we're iterating through the digits in each number within the list of the array. So the sum would then be, then you got to cast it back to an integer. We use number there. And that to the power that is the length of that original number, that the larger number that it's a part of. So to check if it's an Armstrong number, you need to check to see if that greater number, numbers I up here, is equal to the sum you created in the nested for loop. And if it is, you're going to push it to the resulting array. But we had an issue that we'd have a repeated one of the test cases gave a repeated value, and we couldn't quite figure out through debugging what was causing that. So we just included this little if statement. If the number is already included in the array, just if it's not included, I'm sorry. If it's not there, push it to the array. And so we return that array. And so the input was a little confusing. And so this function was already in the test file. So we just use that, and in using jest, we were able to just create the array like it asked. And since you're comparing objects, since they're both arrays, we use to strict equal. And since I'm already in my terminal, I can show you how that looks. npm run test. And that's how we got our little problem to work.
All right, nicely done. Well, thank you very much for sharing that solution. I will say overall, it's pretty clean. One thing I will mention though, that is something that I tell literally everybody, please comment your code. It helps immensely. In the case of like a simple problem, like the Armstrong numbers problem, a lot of people don't really feel the need to comment because it's super easy. There's just a couple of loops, couple of variables. Why would one need to comment it, especially since it's less than like 40 lines at the very most? However, sometimes these small little snippets that you write are used in ginormous projects that literally have thousands of lines of code. And those ginormous projects will often have tens, if not hundreds of developers working on the code. Or it might just be you and like one other person working on the code too, which is entirely possible. And if it's only like, if let's say you're working on code tonight and you come back to it like 5 days later and it ends up being part of something that's like 300 lines long. And if you didn't comment out these 10 little lines in a very integral part of the code, you will be very lost, more than likely. As to what on earth you were thinking and why you were thinking this way when you wrote it. So this is why personally, I always recommend, like, I don't really have a guideline as to how much you should comment. It really depends, but I would say insert at least one comment for like when you're defining your variables, one comment just like explaining like a big block of code. So like your for loop, for example, I would just say like, put a comment that just like iterate through every number, or like where you're double checking the digits, just say something like, calculating sum of digit powers or something like that. Like just like 2 or 3 words but that just says enough to tell somebody exactly what's going on in your code. So if they look at it, it takes them like, they don't have to necessarily know the language, but it'll take them like 2 seconds to figure out what's going on. Does that kind of make sense? Any questions about that? Okay, cool. And Nicholas, that is actually really interesting. And thank you for sharing why 370 gets added twice. So one other little tangent that I will go on before we get to the material for today. This relates to commenting, but also just the problem solving process. especially early on, there's a tendency for folks, and I know that's happened to me a lot too, to just jump right into coding as soon as you see a problem, like just start, defining variables and making your for loops and just like blazing through it, which, can be good if you're working on a project or on a problem that needs to be solved literally 5 minutes from now, because that's what the competition time tells you. But a lot of times in a production development environment, that is a really bad idea, because if you start working on something without thinking through it first, you'll have a lot of problems down the line. So the one thing that I really want to drive home for everyone here is when you see a problem, take a couple of minutes, just think it over, maybe like write out some examples for example, for the Armstrong numbers problem, try to test some numbers on a piece of paper and see if they're Armstrong numbers or not. Or, maybe think about pseudocoding the problem first and just coming up with a map that you can use to code, but also a map that you can use to comment your code while you're going through it. So, just taking it slow, taking it easy, and making sure, that your code is readable to you, not just right now, but also is readable to future you, is something really important to keep in mind. But overall, it seems like you guys are doing great. Once again, Steve and Austin, thank you for sharing your solution. Before we jump into the fun stuff, anyone have questions, comments, concerns, things of this nature? Okay, if no one has any immediate questions or concerns, let's jump into the material for today. So we'll start off with a tiny little bit of review, and then we're going to jump into a problem, which will hopefully be fun, that we can go through to get through some of the fundamental concepts for today. And then after that, I'll let you all go and work on your group stuff. So jumping straight into things. What is a class in Python? Does anyone have a simple definition that they want to share?
I think I think maybe I could explain it and you can correct me if I'm wrong. So I think a class is basically like an object constructor, and so any of the attributes that you give to a prototype or standard class, when you start to create objects of that class, which I think is called inheritance, you end up giving those standard attributes to each object. So I think what the class is an object constructor, simply.
Okay, that's a pretty good explanation. And thank you for sharing that, Elijah. I think we can even take it one step back. A class is an object, full stop. A class is an object that isn't just your simple integer or float or, string. It has a little bit more than that, and it has some stuff in it. And we could use classes in the main use case of classes is if you have something repeated. So for example, let's say that, what's a good example? Something in my room here. Yeah, let's say a light switch or something. If you are let's say that you get contracted to work and create a brand new infrastructure in Python for Home Depot or something. And Home Depot sells a lot of light switches. Now, in Python, you're not going to go and make a separate variable for each and every single light bulb, say light bulb 1, light bulb 2, light bulb 3, and then say light bulb 1 voltage equals light bulb 2, color equals, and so on. That becomes wildly inefficient at economies of scale. So because of that, if we just create a light bulb class, for example, that stores all of the data about a given light bulb, we can just create what's known as instances of that class, or basically examples of the class, which, as you said, they have all the properties of the main class. So all classes are, for all intents and purposes so far, are basically just objects that have special properties that we can play with. Does that make sense? Any questions about that? Okay, cool. So let me go ahead, share my screen. And we're going to get started today's lecture with a problem. So can you guys read my VS Code okay, or is it too small?
I can read it okay. The color kind of throws me off, but
Oh boy, okay. Yeah, I highly recommend VS Code's dark mode options compared to the light mode. It's far more visually appealing. But is anybody else having trouble reading it, or are we all okay? And I'm going to paste this in the Slack channel as well. Come on, Slack. Okay, there we go. So this is going to be our problem that we're going to work on today as a group. So feel free to code along if you'd like on your own, or just watch. Either one's completely fine. So we're just going to do a little exercise to get you guys a little bit more well-versed with classes, functions, strings, that sort of thing. So Joe's Car Emporium has hired you to make them a system for their vast and probably giant car empire. And they want you to make a system in Python that can do a couple of things. So the first one is, instead of Car Emporium, well, they deal with buying and selling cars. And whenever they get some new piece of inventory in their system, in their warehouses, they need a way to add that to whatever code system you devise. So they need a way for you to be able to store new cars or cars that customer order in some sort of software thing, because the people running Joe's Car Emporium have no clue how to code. They do not know anything about programming. So they're just defining this as broadly as possible and saying, write us some software thingy that can do this. So in order to do this, the other thing that they need are, for any car that goes in their inventory, they need to have the following information. They need the make, model, year, color, like options of the car, the owner, the price, the type of car, and for some very obscure reason that we don't know, they apparently want the number of wheels included with every car, which is kind of weird given that every car usually has 4 wheels, but that's what the customer wants, and we do what the customer wants. So there is a caveat that, again, some of these cars are brand new, so some of them might not have an owner at this time, but that's something that we'll get to when we start programming. So the second thing that they need you to do is, since car buyers are people will change their orders. If somebody originally ordered a black car, but then 5 days later, they see that there are too many black cars on the road and they want a red car, you need to be able to work that into your system that you make for Joe's Car Emporium somehow. They don't care how, they just want you to have something that they can type a couple of things into, hit the run button, and then you can, it changes the order in the back end. Also, they want something that lets you check if a car has been sold or if it has an owner yet. And we'll stop there for now. So first up, does the problem statement make sense? Does anyone have questions about what the problem is asking for? Because this is something that I drafted up myself. So if anyone does have questions or if it's unclear, please let me know. And again, this is in the Slack. This should be in the Slack channel as well. So feel free to read it there if you need to.
I think it seems pretty straightforward.
Okay, glad to hear it. So in that case, let's get started with trying to do this. So where do we start with this? What can we do? What should we do as soon as we see this?
Pseudocode?
Okay, I heard 2 people at once. Would you guys mind saying that one more time?
I said pseudocode. And sorry.
You go first.
Go ahead, Lazuka. I'll wait.
Okay, I probably say this. We're saying the same thing. Just obviously create a class for the car employee.
Okay, that's a good thing. And who else?
Oh, so I was going to say pseudocode would be the first thing I would do. Kind of just run through what methods and what I needed to do in order.
Okay. Did anyone else have anything to add? Okay, if not, so both of you guys gave exactly the answers that I expected, which is perfect. So, James, you're exactly correct that we need to start pseudocoding this out first. Here, I'm just going to turn this in. I'm going to not comment for now because I'll comment this all out once we wrap up the pseudocode. But Lizuka, you are exactly right that we want to use a class for this because classes are great whenever we have repeated instances of something. Again, we don't want to create like, car1 color equals car2 color equals and just keep doing that. That gets really tiring. Instead, why do that when we can just create a class that's like, tells us everything we need for a single car and we just, duplicate it and just change it up for the other ones. So let's add that to our pseudocode. So we can say like, what do you want to call this class?
Maybe Car Emporium or Joe's Emporium, something like that.
So that would be good. But does that class name tell us anything about what's actually in the class?
Okay.
So what you're saying though, like Joe's Emporium or like Car Emporium or something, that would be a good name for like the overall like GitHub repo or like something similar to that, but maybe not for the class itself.
Okay.
About like car data or car info or something like that, or vehicle info, vehicle data.
Perfect. All right, so let's call it like car info. And okay, that's it. So now we've started our pseudocode. But before we continue the pseudocode, let's go back to something that Tiffany mentioned earlier, which is we need to talk about what we're looking to do and how we're going to do it. So what are the sort of like, I wouldn't necessarily say inputs and outputs since we're not really designing a function here, but what are the things that our code needs to be able to do or that we need to do in our class?
We need to account for the features that are permanent that all cars have. And then we need to also write the exceptions.
Okay, so things all cars have, things all cars don't have. Okay. So what does anyone know what the name of the first thing, like something that like everything in all instances of a class have? Does anyone know what that variable is called or what that sort of thing is called?
So is it an attribute?
Those are attributes, but I'm looking for something a little bit more specific.
Self.
Or
It's a little bit different. So what I'm thinking
Class
about,
variable?
yes, perfect. Thank you. So things that all instances of a class have are called class attributes. So for an like, let's write some down. So what's an example of something that all cars have?
Wheels.
Okay, so wheels, and how many wheels do they have? Like in general.
4.
Okay, so wheels equals 4. This will, now that by writing this here, this will apply to every single instance of the class that we create. I can make like 15 cars, and they all have different makes and models and whatever other things we want to put in it. But if I tell Python, hey, tell me how many wheels this car has for every single one of those 15 cars, it will tell me it has 4 wheels. Does that make sense? So this is the way that we set up a class attribute. We just write it. Generally, you allow to put all your variables at the top of the class. It's just good programming practice. And you want to set up your attributes all the way to the beginning too. All right, so are there any other things that we need to do in our class overall before we start coding? So remember, we can go back to see what the customer demands up here. So what are other things that we need to add to our class in order to satisfy those demands? And again, they're in the Slack channel as well.
Make, model, year.
Okay, yeah, so let's write those down here. So we can take like basically this whole list and put those in like the things all cars don't have. And we'll figure out how to deal with that a little bit later. I don't want to touch that just yet. But those, so C mentioned that the things all instances of a class have are called class attributes. But what about things that are different depending on each time you make a new thing for the class? What are those called?
Those instances?
So those would be instances. So an instance of the class would be something like car1 equals car info. That would be an instance of the class. But you're really, really close.
Instance variable.
Perfect. Or more specifically, you say instance attributes. Because usually for classes, we like to say attributes. Variables are more used for like functions, if that helps. But yeah, so instance attributes are what we're going to call this. And we can jot those down and code them in a little bit later. But right now, what I would prefer is continue the pseudocode. Okay, so we've got like some of our variables set up. What's the next thing that we have to do when we make a class?
We can set a constructor by like define init.
Okay, so that's what we would call an initialization. So also since I'm assuming everybody here is using VS Code, if you start typing something and it shows up like a text prediction, which most of your VS Code should, if you can use the arrow keys to go between them, and you can also just hit the tab button to fill it in, which is insanely helpful and will save you a lot of time and copy pasting in the future. So I highly recommend doing that. Okay, so this is using a little bit of a funny notation for making a class because it uses the init, then the self, and then it has a little fat arrow here that says basically that it's not going to return anything. You don't really need to include that. It doesn't really help you. It doesn't do anything, but I usually don't include that and I just go straight to the colon. And then we put whatever we want. We'll take out the pass because the pass means skip and we don't want to skip the initialization. We need to initialize this class. So how can we initialize this class? What do we need to do in order to fill it in? There's two things I'm looking for.
So we need to construct instance variables that call upon self, right? So it'd be like self dot make equals make and so on and so forth for all the attributes.
Yeah, so let's do that. So we have self.make equals make. Oops, make now. Okay. Let's see. No, I do not want to import anything. Python loves to do that, especially in VS Code. If you type something and it thinks it's coming from a library, it will automatically import it for you, which is nice if you forgot to import a function like 300 lines ago, but it's not so nice if you make a small typo and then it imports a bunch of libraries and you don't realize it. That's not so fun. But yeah, so we could do things like self.make equals make, self.model. Also, I would caution you from using words like model because things like model, options, type, make, like simple words like that can often be protected variables, meaning we can't use them because they override some sort of like a default thing. So if I say like self.type, it might work here, but it could be a deprecated thing, or it could be used like in some other package. So that's why I would avoid using those. But instead, what you could do is just change it and say something like car model, and then say that's equal to car model. And then here, let's just do some of the other ones. So like self.here, nope, here, no, oh my goodness. All right, there we go. Self.color equals color, nope, not turtle. Self.option, and I'll change this one to car options again, just in case it's protected, and we'll change the color to car color as well. Just again, minimize the chance. Like color here, for example, I type this, it's trying to import it in from TurtlePy, which is a graphic software, because it literally has a package called color, which doesn't make it a protected word on its own, but to avoid conflict, it just makes it easier to say car, because let's be honest, there are really, really few instances where someone will use the word car option or car make or something in another package. So we'll just do like self.price is equal to price. And then let's do just one more. Self.type of car equals type of car. Okay, so are we done here? Is this all we need to do to initialize it?
No, up at if we're gonna have it be put in by the user up at self right after init, we need to put the variables in there as well.
All right, so Austin, I'm going to stop you right there. So that is good. So we can't do this because also VS Code is kind of helpful for once, because if we mouse over it, any of these things with the yellow squiggles, it says car make is not defined because it doesn't know what car make is. It doesn't know where we're pulling it from. And that means we have to define it somewhere. So Austin already hinted at this, but would somebody else like to say what we should do in order to make these quote unquote defined within the scope of the class? It's really similar to what we do with regular functions too.
Would you add them as parameters in your?
Yeah, exactly. So again, the init thing here, init is just a parameter. That's all it is. Init is just a function. And all functions take parameters. So self, for example, self is a parameter of init. Similarly, in order to use the variable car make, in order to define self.car make, we have to make this a parameter in here too. And if we do that and save it, we see that the squiggly line disappears because it says, hey, I know what car make is. Car make is a parameter that comes from my init function. And we can do that for the rest of these as well. Let's see, car options, price, type of car. Okay, cool. So does that make sense? Any questions about how I initialize this? Yeah, there's
Quick
Yeah, go
question
ahead.
is, do we have to use camel case? Is that a command?
No, that's just the way I like to do it. I mean, you're more than welcome to use like underscores as well. That's a really common one. I know some people who just type it all in one, which is, that's that if you like doing that, you can. But please, please, please do not type your variables like this. It is a mess. Just stick to one consistent case, and also ideally stick to one case within a project. So like for me, I love using camel case. So throughout like my entire code, I will only stick to writing my variables in camel case. Other people will, switch it up every now and then, and that's okay too. But just make sure you stay consistent and just make sure it's real. Otherwise, do whatever you want. Does that make sense? Any questions there?
Hey, Umar, also, I saw somewhere before when you guys were typing that you're able to change all similar variable names at the same time. Is that something you could show us?
What do you mean by change all similar? So do you mean like find and replace sort of thing?
Maybe. I saw somewhere where someone selected like car make there. Select all instances of car make and then automatically just replace it. If it's Control F, search replace.
So it's control. So for me, it's Control Shift F, which opens that up. For Mac folks, it's probably Command Shift F.
Okay.
So if you try that, you should get a little search thingy on the right here. And then if you click the drop down, then you get a replace too. So what you could do here, for example, is let's say I wanted to replace all instances of the word price. Note that it does that for everything in your folder. So I'm in my demos folder, for example, so it will replace everything in that folder unless you specify otherwise. If you are in the main directory of your computer and you run the search option, it will go through every single file in your entire computer and replace whatever it is you're trying to replace. So please, please, please make sure that you are not in the main directory of your computer and make sure that you are in the correct folder for your code application. This has happened to me on occasion at least twice, and this has definitely happened to a lot of other students too. I'd like to hope that it won't happen to anybody in this class, and let's try to make some actions to avoid that. So this is basically your search function. Again, you can search up price and it'll show you every single line where price is. I can like literally go to each line for the variable. I can make it like a whole word match or a case match if I want to. I can use regex, which is something we'll do later if we're looking for an expression or if we're looking for something that's like, say like car, if I want to replace all instances of like car 1, car 2, car 3, car 4, I want to replace all of those, we could use regex for that, for example. So basically, use find and replace if you need to replace something basically everywhere. The second thing that's also really nice about VS Code is if you mouse over a variable, like let's say car color, it will show you everywhere that that variable appears in this nice little highlighted thing. So for example, if I mouse over self, like right now, it shows, okay, self shows up in the parameters for init, and it shows up in all of these on the left, which is exactly what we want. So those are some handy little tools that I like to use whenever I'm trying to figure out where something is or came from or being used, or if I want to replace it. So hopefully that helped. And Matthew, does that answer your question?
Yes, sir. And actually, I would just like you're highlighting the variable there. I just right clicked on my Mac and then clicked rename symbol, and you can type in it right there, and it'll change all the variable names too.
Oh, you mean the change all occurrences one or rename symbol?
I actually did rename symbol, but I guess you could do the change all occurrences. But yeah. I mean, you answered my question, so I mean, this
Okay.
this works.
Cool. Well, thank you for telling us about the rename symbol thing. That is really neat. And yeah, that will definitely be very helpful in your large programming projects when you have 3 variables that are all very similarly named, but you forgot to change the names of the variables because you worked on these files 3 weeks apart. So trust me, it is find and replace is one of the most valuable tools in your depository in VS Code. Yep, no problem. Alrighty, so we are nearly done with initializing the class. There's one other thing that that they specified that they need you to include in the class in the problem statement. So I don't want to say what it is exactly, but does anybody, based on what I popped in the Slack, anyone have any ideas as to what the one thing we're missing is?
We need the car owner. Is that correct?
Yep. So that's the one thing that we don't have included. So what we want to do now is we could say car owner, right? And then we'll just, let's say that we do the exact same thing, right? So self dot car owner equals car owner. Okay, that's great. But we have a little bit of a problem. So if let's say like someone's buying, I don't know, like a Ferrari, or let's say that they're getting imported a Ferrari and they don't have a buyer just yet. So do they have a car owner at that point for the Ferrari that hasn't been purchased? Yeah, they don't. But we're including that as a parameter in our class. So how can we make that parameter sort of optional for them to put in? Does anyone have any ideas?
Just take it out from the parentheses.
We could do that, but if we did that, we wouldn't have a way to specify if there was a car owner. Because, for example, someone could, like, they could order that Ferrari and not have a buyer, but at the same time, they could be ordering like a Toyota and have a buyer who's already paid for it. So their name would be the car owner. So if we took it out entirely, that wouldn't solve the problem, unfortunately.
You can set it to a default value.
Perfect. All right. So Nicholas, how do we do that?
You just say car owner equal to, I guess you could put none.
Yeah, we could do none like this in Python. It's quite helpful. Or if you want car owner to be a string, you just set it to a blank string. It's up to you, but always just remember what you set it to. But for now, we'll just set it to none. So by default, that means if we omit the car owner from initializing the class, it'll say that there isn't an owner, which is exactly what we want. And does anyone have any questions about sort of presetting a value like that?
Would
Okay.
it work?
Oh, go ahead.
Sorry. Yeah, would it work? It's the first thing that came to mind. Instead of none, you actually assign something to it. Like Joe's Car Emporium, and then once it
Yeah.
actually gets the owner, you just subsequently change it.
Sure. So let's say we did that. And let's run some test cases. That's one of the most fun parts about programming is testing out what we've done. So right now, I mean, we've got our class for car info. Let me delete this. I'll take out the pseudocode bit there. We don't need that. And let's just create an instance of this class. Now let's call this like car1. And let's say, how do we make something an instance of a class again? Or how do we make a new class object?
The class name and then
Dot notation.
So the dot notation is what we'd use to set the attributes. So we'll get to that in just a little bit. But what Celine's saying here for just putting down car info is exactly correct. So once we do that, we can open up the parentheses and look at that. VS Code is giving us a hint as to what stuff we should put in when we're defining our car. So does anyone have like a favorite like car make or car model that they particularly like?
Camaro.
Yeah, all right, let's do it. So I mean, make the hint show back up. So we'll say the car make going to be Chevrolet. And we can also write these down by saying car model equals, and then we could say Camaro, for example. So it's up to you however you want to do that. And then let's say the year, let's say it's going to be the brand new one that's coming out in 23 with the mid-body engine. And let's say car color equal, let's say electric blue. Here, let me take those out real quick. So we'll do electric blue for that. And what else? Car options. We could say, I don't know, like heated, front seats. The price we'll say is like $70,000. And then we'll say the type of car is sports car. And where'd it go? There we go. And the last thing now is what you were talking about, which is setting the car owner. So what we could do here is say car owner equals, let's say, Omer, and that would change the car owner from Joe's Car Emporium to Omer. Or we could just leave it blank since it's already pre-filled. But let's double check that. So now we've defined the car. And what we can do now is print out car1, right? That sounds like something somewhat logical. So let me do an ls, see what's in my directory here. Okay, cool. I've got my Python demo.py file. And what I'm going to do is do Python py demo, Python demo.py and run it. And okay. So what just happened here? Why am I getting this weird thing in brackets that talks about an object at a weird hexadecimal address? Anyone have any ideas?
Where it's stored in the memory.
Perfect. So that's exactly right. So that's where this is stored in the memory. It's not, when you print out a class in Python, unless you tell it otherwise, it's not going to print it out in a very nice, pretty format. It is going to tell you the memory address. It's going to tell you what type of class object it is, and that's it. So this is telling you that this is that car1, which is what I'm telling it to print, is a car info object, an instance of that class at this memory address. That's all. It doesn't tell us anything further. So if we wanted to tell us something further, then we need to specify using the dot notation what we want it to tell us. So what I could do here, for example, is say, well, let's say that I want to get the price of car1. Then I would do print car1 dot price. And if we run that, we get that the price is $70,000, which is exactly what we want. Or let's say that we want to get, say, let's say we want to find out who the car owner is. And I would do car1 dot car owner. And now remember, in car1, did we specify who the car owner was? No. So what do we expect when I ask for who is the owner of car 1? What should I expect to be printed out?
Should be Joe's car Emporium, the default value we set.
Perfect. Yep. So let's see if that actually happens. If I hit run now, yep, we get Joe's car import, which is exactly what we expect. Or, let's say that I replaced Joe's car import with like a none or a null value, and I reran it, then it tells us none, which is exactly what we want. So now though, let's say that I specify here that car owner equals, let's say, if I do that and I hit run, the car owner that we specify in the class instance down here is going to override the default that's in the class. So basically it's saying like, if I input something for car owner, then override this. Otherwise, just go to the default. And if we run this, we see that I now show up as the owner of this lovely 2023 Camaro. So does that make sense? Any questions about setting up the classes or making the pre-filled parameters? Okay, if not, let's go ahead and take, say, like a 6-minute break, and we'll come back maybe around 6:45. How does that sound to everyone? Okay, I will see you guys in 6 minutes. Feel free to take a break, grab some water or something, and if you have any questions, feel free to send them in the chat here or via Slack or DMs. It's fine too. And I'll talk to y'all in 6 minutes. All right. So break's over. Time to get back to work. Let's go back to our Python demo. All right. So just before this, we wrapped up making our car info class. We made a class attribute for the number of wheels, and we created our initialization function with everything that our client Joe's Car Emporium wants. And we also set the optional parameter for car owner and set a default value for it. So now we're basically done with the initialization part of our class. What else do we need to do with our class? What else does our client want from us? If we go back to look at the prompt.
Show the
If
inventory.
somebody changes, you have to show that it's changed.
Okay, yep. So how can we do that? So if somebody, let's say someone orders this Camaro that's in car 1, right? But let's say, they decide that they don't like electric blue for whatever reason. Let's say they want to change the color of the car to, I don't know, purple or something. I don't know why, but let's say that they do that. How would I change the color of that car to purple?
Could you just do car1 dot type or car color equals purple?
So let's try that. So car1 dot car color. So what does this do? So what this does is it first tells us, all right, we want to change something about or access something for car 1. What's the thing we want to access? Car color. So Python will go from this statement all the way here, and then it'll go to this thing. So what we can do is we can just print out the car color. We don't want the owner right now. And let's say that we want to change this now to purple. And we can print it again just to make sure change has gone through. So if we run this, we see that first we print out car color, it prints out our electric blue, but then it goes in and says, all right, we're going to go up to car 1, I'm going to go to that car color, and I'm going to change it to purple. And then if we go back down here, we print it out again, and we see that, yes, indeed, the color has been changed to purple. So this is the easy way to change a class attribute. Now, there is a harder way to do it, but this is a way that is very important for everyone to learn. We can change it through a function in the class. And there's a reason for why we would do it this way. Does anyone know why it would be better for us to, say, define like color change function in here instead of changing it using dot notation outside?
I mean, it's easier to call instead of using dot notation.
Yeah, that's very valid. It really is easier to call. The other thing that we can do with this is, let's say that for some reason, like for car owner, for example, let's say that somehow we decide to set car owner so that no one can access car owner outside of this class. We set it to be like a private variable. Then the only way that we can change a private variable is going to be inside the class. So if we ran something like car1 and assuming car owner was private, car1.car owner, it would be like car owner doesn't exist outside of this class. You can't call it outside of here. But that's when we would use this function, like the owner change function or something. That function resides within the class, so it can change it. So for security purposes, it's always a good idea, especially if you don't know if some variables need to be secured or not. It's always a good idea to make sure, A, that the dot method works for easy, quick fixes, but for other things that are deeper, you want to make sure that you have a method inside of your class that can do it as well. So let's say that I wanted to make a color change method. What do I do? How do I do this?
It would take
So
a
the-
string. I mean, I'm sorry, not string, just a variable.
Okay, so it would take a variable. What do we want to call that variable? Any ideas?
Wouldn't it be self?
So that's one variable. So you're right. So both of you are correct. There are two variables that we need here. The first variable, whenever you create a function in a class, always include self as a parameter. Because otherwise, if let's say I didn't include self, let's say I just included, let's call the new color literally just new color and be really boring about it. If I typed in self dot car color in here, which is what we think we'd do. Hey, check it out. We got a little squiggly line. What does the squiggly line say? Nope. Show me what the squiggly line says. Self is not defined. So this becomes a little bit of an issue with global and local scopes, which is something we'll talk about later. But basically, whenever you have a function inside of a class and you're accessing a class attribute, you have to always write self in the parameters. We do that for the init function. We do that for the class methods. We'll do that for descriptors. Anything within a class, whenever you're writing a function, make sure to use self. Does that make sense? Any questions about that? Okay, so if no one has any questions about that, how do I set, so we already talked about the self.car color part here. How do I set that to my new color, whatever that is?
You just set it equal to the color?
Sure. So we can say set to the color. And now let's say that I wanted to print out a message that says what this color was changed to in the function. So how would I do that? So I would say like something like color changed to, and then now what? If I want to say what the color is that it was changed to. There are a couple of ways of doing this.
Do you use the brackets and include the self that, no, new color? Wait.
Yeah, like
Okay.
the F statement.
Self that,
Yes.
Yeah.
Yes. So it's not an F statement. It's called an F
Or-
string. But
Yeah.
you guys both got it. So we have to first type F in front of it. And then wherever you want to put a variable, put a bracket and then close the bracket. And then whatever you put inside of that bracket is not going to be part of the string. That's going to be your code. And in there, we can just put self.car color. Or we could change it to new color as well. So also here, I just realized that I disobeyed my cardinal rule of commenting every method. So here for color change, it's kind of obvious, but still for bigger methods, not so obvious. But it's a good idea to get into the habit and just say changes car color to user input color. Something really simple. So let's make sure that this method actually works then. So how would I check? Let's say that I wanted to, again, stick with our car one, the Chevy Camaro. Let's say I want to change that from blue to purple. So how can I do that using this method? So what would I do if I wanted to replace this line and I want to use color change? How can I do this?
You could say car1 dot color change, and then within the parenthesis, you can put in the new color.
All right, so let's try this and see what happens. So we'll run it, we'll see what it outputs, and then we'll explain why. Okay, so the first thing, ran it and it says electric blue because remember here, we haven't changed the color yet. We're printing out the original color. Our color is electric blue. The next thing is it goes down here and it says, all right, car one, I need to do a color change. A color change, we know that that's a thing defined in the car info class. If I then goes into car info and goes to color change and it says, all right, self, you don't need to write self here. It skips that. And that says new color. So the variable new color gets set to purple. So that's what we set in the input. Then it sets the car color to our new color, which is purple. And then we print out our F string, which says color change to self.carColor, which is purple. And then just to double check down here, we've got our print statement that does indeed tell us that the car color has been changed to purple. So does that make sense? Any questions about this? Okay, yeah, there is one other way that we could have done the print statement without using an F string. And it's a method I don't like as much, but it's a little bit easier, but also more finicky. So I'm going to take this out. And can someone tell me what variable type or what type of object is this? Is it an integer? Is it a string? Is it a list?
String.
String. Okay. Now, what about car color? What is car color? Is that a string as well? Is it an integer? A Boolean?
Also string.
Right. So if we have two strings, they're the exact same data type. So because of that, we can literally just add the strings together and it will combine or concatenate them into one string. So if I run this again, we see down here, it does color change to, and then here it'll do plus purple. And again, they're both strings. And because of that, it'll just combine these two and say color change to purple, like so. So if you definitely 100% know that your thing here that you're adding to it is a string, then you can always just use the plus sign and it makes it nice and easy and simple to read. Or you can use the F string method. I like the F string method a little bit more because that way, you can put in integers, you can put booleans, you put whatever you want inside of there. Some other people prefer using the plus method, but it's good to know both just in case you see them. So that's how we can do our color change method. And again, we're not going to go through and do more methods like this for each and every one of these because that would just take a lot of copy pasting. And let's be honest, that's kind of boring. But does anyone have any questions about that so far? Okay, so there's one more thing that we have to do for our car class before we move on to the dealership one. What's the last thing that we have to do for the car class? Going back to what the problem says.
I think someone said earlier it's to show an inventory, a pretty looking inventory in the console.
So that's the last thing that we're going to do like all the way to the end. So what I'm talking about is, so let's start from the top and see what we've gotten done. So we figured out how to store new cars / orders in a class. We included all of the features like the make, model year, color options, owner, and all of that. We did that if someone changes their order, like changes the color, reflect that in the class. And now we have this one. So check if a car has been sold or if it has an owner. So we need to come up with a function that checks if a car has been sold or not. So what can we maybe call this function? Any ideas for a name?
Is sold.
Perfect. Keeping it simple but descriptive. I like it. And then we'll put that here and we'll say checks if car has been sold / has an owner or not. So what do we put as the parameters for this function? What's the one parameter we have to put in?
So,
Self. Do we need to put in any other parameters here?
well, we want to change owner, so we should probably describe, like maybe new car owner. Maybe.
Do we want? Well, let's see. Does the purpose of the function to change the owner, or is it just to check if there is an owner?
Okay, yeah, that's what you're saying.
So,
So
we
do
need
we-
to pass an instantiated car. Is that what's going on?
Nope. This is
Oh,
all
okay.
within the class. It's all within the class.
Do we just leave it and then just when we call it, do blank parentheses?
Exactly. That's all we have to do here. So the only input we need is self because we're not trying to add in any additional parameters or change anything. We just need to use self. So now, how do we, so just for convenience sake, I'm going to change the car owner here to none, just make it a little bit easier for us when we're writing this function. So how do we check if a car has been sold or not?
If
We
the
use
car,
the if Go ahead, Matthew.
I was gonna say if the car owner has a name.
Okay, how do we check this? Yeah, we can go back to our init statement here. How do I check if the car owner has a name?
Well, earlier we did print car1 dot car owner, and then if back is none, then it didn't have an owner. So I guess we
Okay.
can something in here to print that, or maybe like a checking function.
So printing wouldn't help us here because all printing does is it just writes it to the console. The computer doesn't do anything with that information. So
Would you do
printing
like-
just sends it.
Would you do like
Go.
if self dot car owner equals none, return there's no owner, and else return self dot car owner?
Okay, let's see what we do else. Return. So else would mean it has. So remember, so going back to the purpose of this function, the only purpose of this function is to check if the car has been sold or has an owner or not. So this is an if it has or not. That means this is basically going to be a true or false question. Has this car been sold? Yes, it has been sold, or no, it has not been sold. So what you're getting at would be something like, has the car been sold? And if so, who was it sold to? Which is a little bit more complicated than what they're asking for. Does that make sense?
Yeah, so you could just do like return self dot car owner equals none.
Perfect. That's exactly what I was going to drive at. Because look, it saves you so many lines. You don't even need the parentheses, but I just like them because it makes it easier to see. But instead of doing like if self dot car owner is none, return true, else return false, we can just return this value on its own, say return self dot car owner equals none. So let's test that out right now. So what we could do here is change this to car owner, change that to car owner. And now I think Tiffany already answered this, but I'd like to hear somebody else answer it as well. How do we check if car one has been sold or not? Yeah, ideally somebody who hasn't gone this class. Okay, or maybe someone who has gone this class. That's fine too.
Would you just do like print? Hold on. How do you call the function inside of the class? Would you do?
That is a good question. Does anyone know how we would call a function from inside of a class?
Dot notation.
Okay.
Just dot is sold.
Right. So what we would do here, we do car1 dot is sold. But is sold is a function, right? So can I just leave it like this? And just put the is sold as is? Or do I need to do something else?
Empty parentheses.
Perfect.
Yeah.
Now, why would it be empty parentheses?
Because it's just you just need the parameter self, and you're not going to type anything in. You just need.
But you
where
just said I
function
need
is
the
at that
parameter
time.
self. So doesn't
Well,
that
but
mean
it's-
doesn't that mean I need to type in self right here?
Well, that's an argument. You don't need an argument. You just need the parameter that's in the function.
Yes. All right. So that's exactly what I wanted to hear. The only time you will use self is when you are inside of the class itself. Whenever you go outside the class, whenever you deal with the class instance, no self. The only time we'll use self is inside the class. So car1 dot is sold. So what do you think? Right now, does car1 have an owner? Probably. Unless Python does something very weird in the background. Should it tell us that it has an owner or no?
It might tell you the opposite.
Why would it tell us the opposite?
Because we're returning a Boolean if there is no owner.
Ooh,
True.
okay.
Yeah.
Right.
True.
So what we're really saying this function is not sold, but that's not what they want. They want us to figure out if it has been sold. So how can we change this from telling us if the car has not been sold to if the car has been sold? It is a 1 character difference.
Put an exclamation mark.
Yeah.
Where do we put the exclamation mark? There's 2 places we can put it.
In front of the equals. Or yeah,
So like right here?
that's what I would do, because it's not if return self.car owner is not equal to none.
That's one option. The other option that does the exact same thing is just put the not operator out there. Or, no, it'll be not. There we go. That works too. But basically, either one of those, this one will just say, hey, turn this entire thing, flip it around. If this is true, then it'll return false. Or if this one will just say, hey, are these two not the same thing? If they're not the same thing, then we're good. So, does that make sense?
Is
So-
one option better than the other, or is it just kind of readability?
It's up to
choice?
you, honestly. They both
Okay.
do the exact same thing. It's dealer's choice, honestly.
Cool.
So let's run this and see what happens, just to make sure. So we run it. So now it says, all right, that the owner is none, which is exactly what we set our default value to be, and is sold is false because none equals none. And that means that this return statement is false, which is exactly what we want. Now, though, let's say I set car1 dot car owner equals, let's say, James. And now let's say that I run this again. What do you think will happen? Should it tell us it is sold or isn't sold?
It's
Should
sold.
tell you. Yeah, it should tell
Is
you
it one
that's been
equal?
sold.
Yeah, one equal to
Perfect.
none anymore.
Yep. So if we run it again, just to double check, it says true. The car has been sold because the car owner is the string James, which is not equal to none. So James, congratulations, you are now the owner of this brand new Camaro. All right. So that was part 1, where we did all this stuff for the car class. Does anyone have any questions about that before we move on to the dealership part?
So I mean, I guess just if you want to go by exactly what this what the instructions say, if somebody changes that order, reflect it, would you need to make a function like color change for every single attribute?
Yep, every
Yeah,
single
and
one.
that's kind of what I was thinking, and that's a bit cumbersome.
Yeah, we're not doing that here though, don't worry. But also, a lot of the time, if it's something as simple as this, literally copy,
Yeah, just copy and
paste,
paste, change
and just
the
change
name.
color to options or owner, whatever, find and replace. They'll get it done in 5 minutes. So it makes it a lot simpler that way. But yes, in general, if they do say we want to update the we want to have something that lets you change every single field, then you have to make a new function for every single field. There are other ways to do it using like software packages and stuff, but this is just the most traditional and honestly the easiest way to get it done. Any other questions about that?
How do we check customer orders? I don't see that in it.
Oh, so I'm just saying like new cars and customer orders are the same thing. So those are they're identical.
Not a
Yeah.
separate category. Okay.
Yeah, they're both the same thing. They're both within this. It's the car info. So all right. So we got our car class working. So now I have all of these test cases here. I'm just going to comment all of this out because we don't need it. And now let's move on to the next part, which is going to be our dealership things. So what they want us to do is something called create, read, update, and delete, or CRUD, cars from dealerships. So CRUD is a word or term that you are going to hear a lot of in full stack web development, because this is basically the essence of every database ever. So they want CRUD is, again, create, read, update, delete. Create, I want to be able to add a car to a dealership. Read, I want to be able to access a car from a dealership and get its properties and print them out. Update, I want to be able to change something about the cars in the dealership. And delete, I want to be able to remove a car from the dealership once it gets sold. So does that make sense? Do those 4 characteristics make sense? Any questions about that? Okay, if there are any questions about that, let's get started making this dealership class. So would someone like to maybe talk through how they would start making this dealership class? Okay, or if not, that's fine too. But what's the first thing that we have to do whenever we want to make a class? How do we create a class?
The word class.
All right, class. What next?
Then you name it.
All right, what are we going to call it?
Do we want to go simple here and just do dealership? Maybe.
Yeah, sure. Dealership, or we can do dealership info. Since we called this one car info, we might as well just call this one dealership info. Colon there. Okay. What now? What do I do from here? So again, go back here. We want to set
initialize.
We can do that. Or let's think about our attributes first. So remember, we've got the class attributes. Here are the things all dealerships have. And the instance attributes, which are, the things that change dealership to dealership. So let's keep this as simple as possible. Let's say we're not going to have any class attributes, but the instance attributes that I want, those are things, those instance attributes. Let's say I want to have like the name of the dealership, and then I'll say cars in inventory. So now let's do what you were suggesting and create the init function. So do define, and where's my init? Init, take this out because we don't need it. So what do I do from here? So we've got ourselves. What else do I do in order to initialize a dealership?
So for here, we would do like dealership name, and then maybe cars our car's inventory, maybe.
Yeah, so we can say car inventory. All right, so what do I do from here?
Be self dot your new variable name equals that variable name.
Okay. And then we could do the exact same thing for self.car inventory equals car inventory. Okay, cool. So our init function is done. So now, what type of variable is dealership name? Is it giving us an integer, a string, a boolean, a custom type? What sort of variable are we talking about? What are we looking at?
String.
String. All right. Let's jot that down. It's the string. And what about car inventory? This is a little bit more challenging.
It need to be a dictionary, possibly.
Okay, that's one
Or just a
option.
list.
Let's go really simple. Just make it a list. And what is it a list of?
Cars.
Cars, make model.
Oh, yeah, so it's a list of cars, but cars are not a thing in Python, right? So is it going to be a list of integers, a list of strings, a list of class objects, a list of booleans? And that's up to us, the programmers. So what do you want to make car inventory a list of? Keeping in mind what we just made up here.
If we do class objects, does the class dealership info need to extend car class to be able to access that, or
No, because
Okay.
so dealership info is not inheriting directly from it. Dealership info is a separate class. Car inventory or car info is a separate class. They do not intersect in that way. So there's no inheritance. There's no need for them to share anything. Does that make sense?
yeah, that makes sense.
Okay. So yeah, so this will be a list of car infos. Because look, we already set up the class here. It's the easiest way to store car data. And the whole point of the system is so that we can store all their car data in the dealership class, right? So are there any questions about why I decided to make car inventory a list of car infos? Okay, I'm going to assume that there's no questions on that at this time. So we set up our dealership class. So now what can we do? What are the other things we need to do? So if we look back at our create, read, update, and delete cars from the dealership things, well, we need to write functions for each of these. We can do create, and I'll just say that this is basically add car to dealership inventory. Then there's going to be read, which is going to be like print, which is like access car in dealership inventory. Then we're going to have update, which is obviously updating car info in dealership inventory. And then we have remove, which is, or well, delete, yes, which is just the same thing as remove car from dealership inventory. So let's start writing some functions for each of these. So let's start off with create. So how do I add a car to the dealership inventory? What would I do?
You'd have to add a car object to a list.
So say adding a car info object to car inventory list. Right. So let's do that. So first thing we need to do is define a function to do this, right? So what do we want to call this function?
Add car.
All right, yeah, keep it simple. Add car. So what are the parameters of this function going to be?
Would it be
So-
self and a car object?
Yeah, so we'll say self, and then we'll just say, we can honestly call it car object. That's fine. All right, so now where do I go from here? So I've got my add car function, and I have the user input. The user is going to tell me what car they want to add. What next? What do I do?
So I personally would check to see if the car already exists within the list that we have, and then if it
Okay.
doesn't, add it to the list.
All right, that's one option. But let's say that the company decides to order 20, I don't know, 20 like black Lincoln Navigators or something. All of those Lincoln Navigators are going to be identical because they're all black, they're all the same model year, they have the exact same features. So all of those car objects would be identical. If we had them like a VIN number or like product ID or something, checking for, making sure it wasn't added previously is a really, really, really good step. But we're just trying to keep it simple here, just as an exercise with classes. So we won't need to be doing that checking. But I like the fact that you're thinking about this. So not tonight, but we will do this in a future exercise. So all we need to do here is just add it to the list. So how do I add car object to the inventory list?
Would you just initialize car object as a new, like in the car info, like do the initialization? Like
So-
car object equals car info.
So car object here is already going to be an instance of the car info class. So if car object here would be like car one. So if I wanted to add car one, for example, to car inventory, I would put in car one as the input to this function.
Oh, would you just append it to car inventory?
Okay, how do I do that?
Car inventory dot append car object.
All right, car inventory dot append car object. Okay, I'm getting a squiggly line here. Car inventory is not defined. Uh-oh, how do we fix this?
Oh, do I have to do the dealership info dot car or maybe bracket? No, dot notation.
Anyone else have any
You need
ideas?
self.
Yes, you need self.
Yeah, you need self.
Why? Because otherwise it doesn't know where you're getting car inventory from. Car inventory could also very easily be a value that you describe that you name up here. You say car inventory equal 1, 2, 3, 4, 5, or like something like this. And then it'll say, okay, yes, I know what car inventory is. Car inventory is this thing. No, car inventory is not this thing. We want the car inventory to be the thing inside of our class, which means that we have to put ourselves in there, because then it'll say, all right, I know which car inventory you're talking about. You're talking about the car inventory that applies to me. So I'll go here and I'll do the car inventory that was initialized and I'll append that. Does that make sense? Okay, cool. So that's the first function done. Create, adding the car. Now the next one, we can do, let's say we want to access or return a car in the dealership inventory. And let's make it a little bit more complicated. Let's say that we want to just do it like by make or by model. Let's say. So let's say I want to basically get like all the cars, or let's say I want to get a specific car that is like the first car that's a Toyota or something like that. So let's say we could do define turn car by make. So what are the inputs I would put into this function?
We need self first.
All right, we always need our self. Self, so what next?
Car model.
Yeah. Okay. So now comes the fun part. What do I do from here? So this is where our pseudocoding comes in handy. So how can we go through all the cars in the dealership inventory and find, let's just keep it simple and assume there's only one car per model in this dealership. How can I find that one car that is that specific model that we're looking for.
We have to use a loop.
Okay, how can we do that? What would we loop through?
We throw all the car models to find the one we want.
Okay, so how would I do that in code? So we'd have to do for, but what would come after the for?
Oh, just a variable, any variable you want to call.
Okay. What do we want to call it?
Model. Would you do like
Model,
for
yeah.
model and car? I guess they're car info or
Okay.
car. Hold on, we're looking through the inventory
Yes.
in car inventory, right? Because
Yeah, so let's say we can do like for
list
car.
of car.
We can do like for car in. Now, do I just type car inventory on its own like this? Or do I need a little something before?
Self.car
Yes.
inventory.
Always do the self, and VS Code will help you with the little squiggly line. All right, so now what do I do? So let's say that I'm going through all the cars in car inventory. What do I want to check? What's the feature of the car that I want to return?
You're looking for car model, but never mind.
Yeah, we have return car by make, but then the attribute we're passing is car model. So
Oh well, all right, here we'll change it to car model.
Is there an issue with naming them the same? That class attribute of car, is it the same as this argument that we're looking at, car model?
No. So
Okay,
car
okay.
model here is a different thing, right? Because car model is the thing we're inputting. Car is just the arbitrary variable that you define. That's going to be the thing that we're using to keep track of what we're looping through.
Okay.
So they're two differently named variables. We never want those to be the same.
Do we say car equals self.car model? No.
That's on the right track. But so let's write down some comments, right? Let's figure out what we need to do. So what this one does is it says like basically go through each car in inventory. And now what we want to do is first, what do we want to do here? We want to say like check if the car is the model we're looking for, right? Because if it is the model, what do we do? If it's the right one,
Return it.
all right. So I'll add that kind of if it is, return it, and that's all. So how can we check if being the really key word here, the car is the model we're looking for?
we can do car model equals to the input. Yeah, the input car model.
Okay, but now what type of equal sign? Is it 1? Is it 2, 3? Is it like 10? How many equal signs do I use?
2.
2. Okay. Is there anything else that I need to put on this line?
Just turn it into an if statement.
Okay, how do I turn it into an if statement?
If, put an if in the beginning and then a semicolon at the end.
All right. So that's our check. And now what about for returning? How do I do that? It's actually just
Return
words.
You want to return the iterator, the car.
Yes, that's it. So now though, if the car does exist, we return the car. But let's assume that let's say that this is like, I don't know, let's say this is like a Toyota dealership. And by accident, the dealer who's running it says that they search for a Mercedes or something instead. And they can find a Mercedes because they don't sell them. So we need to have a contingency saying, if the car isn't found, we could probably, let's say, return none or something like that, or return no. So to do that, because we ran through the entire inventory already, we exhausted the inventory. It's not there. So we go outside of the for loop, and now here we can just do a return null, or return none, I suppose. Because that basically just tells us that the car hasn't been found. Does that make sense? Any questions about this function?
Now, is this just returning the first car it comes across in the inventory that matches
Yeah.
the model? Okay.
Yeah,
so
we're
it's
just
not
keeping it
returning
real.
all-
We're just keeping it real simple. We're just returning the first one. You could make it return all of them, which it wouldn't be too difficult of a change. But for now, for tonight, we want to wrap this example up so that way you guys can have fun in your groups working on the problems. But for right now, we're just gonna stick to return none and returning only one instance. Any other questions about reading or accessing and returning, anything like that? All right, so there's two more functions that I want to include here, and we won't do the bonus tonight, but we can do that maybe some other time, or you can work on it on your own if you so choose. But now let's do updating car info in the dealership inventory. So let's say that somebody has a car. Let's say that the dealer wants to update, let's say like the second car, and change the attribute. Or actually, updating is a little bit general, so we'll skip that for right now. Let's say that we'll just skip the update. Let's just move on to deletion, because updating here is going to take a while because we have so many attributes. Let's say we want to remove a car from the dealership inventory. So let's do the exact same thing that we did for the last. How do I remove a car from the dealership inventory? What do I have to do? First, we need to define a function. We can call that function remove car. What will be our inputs to this function?
Self.
Okay, self is one. What's the other input that we need?
A car model.
So we could do car model, but in this case, let's say that we actually give the specific car object that we want to remove. So let's say let's say that car one is in there, and then car one gets sold. So we'll just say remove the car one. We'll just put in car object for now. Keep it real simple. So how do I remove this from the inventory? What do I have to do that?
Could you do self.car inventory pop, and then it takes in the car object?
All right, so let's look at pop. So you're saying just do car object like this?
Yeah.
Okay. What do the rest of y'all think? Do you think that would work?
I think pop takes the last element in the list. Remove the last one.
Yeah, so pop. Oh, go ahead.
I'm sorry, go ahead.
Oh, no, go ahead, please.
I have a question. So the argument car object, is it called by value or is it called by references?
Oh, that's a good question. So this is going to actually be called by reference because it refers directly back to the object.
Okay, thank you.
Yep, no problem. But yeah, that is a little bit of an advanced question, but I like the fact that you're asking it. But basically, call by value basically says it just makes a new object that has the same value, which is not as great. Whereas call by reference actually goes to the precise memory location. But that's a little bit of a tangent. But yes, in Python, this is a call by reference. So going back to the issue with pop from the list.
So pop is by index, right?
Yes, that's the problem.
Correct.
So
my
we'll
bad.
have to, no, you're all good. So that's why we have to use remove instead. But we have a problem. What if the object doesn't exist? So let's say, again, let's say that, like, you know, it's a Toyota dealership or something, and then somebody decides that they want to remove like a Honda Accord. Now, a Honda Accord doesn't exist in a Toyota dealership. So if you try removing it, you're going to get a value error because it'll say, hey, this isn't in this array. This isn't in the list. I can't remove it. I'm throwing an error, which is not what we want at all because that'll cause our code to crash. So what can we do to prevent that from happening?
Just use an if statement to match if it's in there.
Okay, so how do we check if the car is in the inventory at first? It's actually very similar to the words you just said.
It's if car object not in, correct?
So we want to check if it is in, right? Because if it is in the inventory, then we can successfully remove it. If it's not in the inventory, then we have problems.
Oh, okay.
So how do we check if it is in the inventory?
If car object in car inventory.
Do I just type car inventory like this?
Self.
Self.car inventory.
Yep. It'll take a little bit of getting used to. I know it did for me, but once you guys get coding with it, you'll get it. It takes a couple of days, but soon self will become part of yourself and your coding. All right. So if it is in the inventory, remove the car. But what if it's not in the inventory? Then what should we do?
Let me get some type of error message as a string.
Continue.
Yeah. So personally, what I would do is I would want to tell the person who's tried removing the car, just say like, car not found in inventory could not be removed, or something like that. Or similarly, like for the above one where we tried finding a car and we're trying to find model, we could just say car with specific model or specified model not found in inventory. Like just give like, a helpful little thing to the person who's putting in these commands, just so that when they put them in and they don't see anything happen, they're not wondering what just happened and why did this not give me what I expected. So introducing those little print statements can be a nice thing for people on the other end. Does that make sense? Any questions? Okay, so now that we're done with our class, the last thing that we're going to do is just test it and make sure that our class actually works. So I'm going to copy car one. I'll just make like two more that are like slightly random. We'll say it's like a Toyota Camry. Change this to like red, and we'll say, I don't know, spoiler. Say it's like 30,000, and we can say like family car, and then we'll just make one last one, which is like, I don't know, Honda, like Pilot. I'll make this like an older one.
That's the exact thing I was thinking of.
Well, I'm glad we're thinking on the same page. We could say this is like black. We could say, I don't know, climate control. Make this like 40, and then we'll call this like an SU. So now let's say that we have like dealership one, right? We're just keeping it really simple variable names here because this is just for testing. So I want to make a new instance of the dealership class that has all of these cars in it. How can I do that? So how do I make a new dealership, a new instance of a dealership?
We'll do that dealership one. one equals, oh no, I lost it. We'll do the dealership info function.
Okay, so do I just leave it like this? If we go back and look at our init function, we have to put in a couple of parameters, right?
Yep.
So so what would I do here? So I put in the name of the dealership first, right? Dealership. And then now I'm going to put in my car inventory. Let's say I'll make it car 1, car 2, or we'll just do car 1 and car 2. We'll leave it there. Right? So the first thing that we can do is let's just print out dealership 1.car inventory and just see what's in the inventory list, right? Print this, hit enter. And we'll fix this very soon in like 5 minutes. But we see that it prints out 2 objects, which is exactly what I'm looking for, right? It prints out our first object, which is probably car 1, which is our Camaro. It's got a memory address. And then it prints out some memory address that's more than likely for car 2, which is what we want. The next thing that we can do is test adding a car. Right. So what we could do here, how do I add, let's say I want to add car 1 to my dealership. How can I do this?
Dealership 1 dot and call method.
All right. So dealership.1 dot add car. And then what would I put inside of add car?
Car 1?
Yeah, because we just need to specify. Whoa, that's not what I want to add. Let's put car 1. Where did that come from? Add any imports? Perfect. But yeah, we just want to add car 1. We just need to specify what we're adding. And print the inventory again. So initially it has 2 memory addresses. Now it has 3, which means that yes, indeed, we are printing out car 1. Now the other thing that we could do is, let's see, what type was car 1? I'll move this all the way down to the bottom again. Car 1 was a Chevy Camaro. So let's go ahead and test our return car by model function. So what I want to do, we could do dealership.1 dot return car by model. And then in here, the model should be Camaro. Yes. So if we do that, I should get the memory address for object 1. So we double check down here. Is this object, which is the object we added, car 1, is that the same thing as this object? They have the same memory address. So it worked out. So this did indeed return the Camaro to us. And if we wanted to double check that, we could do is do dot car. And that would actually tell us that the model of the car that we returned is indeed a Camaro, which is perfect. And the last thing that we could do if we wanted to is, let's say that we wanted to remove car 2. We do dealership 1, remove car 2, and let me just clear this, run it one more time. So we start out with 2 objects, then we get 3, and then we remove the middle one, and the middle one's gone. So all of our functions work. Any questions about the example that we just ran through?
I got a question.
Please go ahead.
At the very top, we declared wheels as 4 for every car, right? So that's the class attribute.
Yep.
So if I want to find out how many wheels car 1 has, how do I do that?
Well, you do it the exact same way that you find out what the make and model of the car are. All I would do, you print car 1 dot wheels, because wheels is, sure, it's a class attribute, but it's still an attribute of the class. Because of that, we can access it just like any other attribute. They just use the dot notation. So for any attribute of a class, we use dot notation to get to it. Just like for any function, we use dot notation to run it. But yeah, that's a good question. Any others? All right, so if not, there's two more things that I want to show you tonight before we end. Number one, not OneNote. Clear this. If I run this, let's say I just want to print out car1, right? If I run that and print out car1, I get this memory object. I do not, as a normal human being, I do not know what on earth, I do not know what on earth this is supposed to mean. I don't know if this is a car, if this is a plane, or if this is somebody trying to hack my computer. I would very much like to know what is actually being printed out. So in order to do that, let's minimize dealership info for now. And let's delete a bunch of this white space. Let's go back here. So in order to come up with a nicer format for whatever gets printed out in our console, and here, I'll bring car1 back up so that they're not bouncing all over the place. And I'll bring my print statement back too. So in order to make it a little bit nicer to print out, what we can do is define a string method. So have any of you guys seen these before? No? Okay. So this works exactly the same as an init method. So when you have the double underscores, which basically means it's going to overwrite something. So for the string method, what we need to do is this is going to return a string. And the string that it returns will basically be like a summary of our car info. So that way, when we print it out, we print out whatever car1 is. Instead of printing out the memory address, which again means absolutely nothing to a normal person who's using the system, what it will do is it will say, okay, hey, you defined a custom string method. That means that if I'm going to print out car1, that means you want me to print something different than the memory address. And then it's going to print out whatever we return in here. So for example, let me see, I think I have this written up. Let me pull that over. So I made like a little app string of this when I was solving the problem on my own earlier, where like, you have like the car type and then the year and then the model and make and then options and so on. So just using like a little app string in order to, that was not what's basically just using a little app string in order to make sure that, it included all the features that I wanted in there. Does using the app string there kind of make sense? So if we run it right now, hopefully this shouldn't throw any errors. Nope. Car info has no attributes color. There we go. There's another reason why variable names are really important. But if we rerun it now, we see that instead of returning this ungainly memory address, we now return sports car 2023 Camaro Chevrolet. Okay, that should probably be flipped around. But electric blue with heated front seats for $70,000, which is that's exactly what we want to print out. Let me shift. There we go. And now it prints out like normal, and it says 2023 Chevrolet Camaro, which is perfect. So using the string method is really helpful if you want to display a class or print a class out nice. So, does that kind of make sense? Any questions there? All right, so now there's one other thing. So let's say we've got my car1, I've got car2 and car3, and I'm going to make my dealership, and I want to print out my dealership car inventory. If I do that, whoa, this is kind of weird. Here, let me just make it 2 cars. So thing is, if I print out car1 before, clear that one more time. So if I print out car1 on its own, it prints out car1 in that nice string format that we came up with before. But if I print out an array or a list with car1 and car2, it goes back to printing the memory addresses. That feels like it shouldn't happen, But there's a reason for this. And the reason is that in our car info method, we did not specify a repr method. And that basically means like similar to like repeat. So basically, the string method tells us what to do when we're printing one instance. The repr method tells us what to do when we're printing out like a bunch of them in like a list or a tuple or a dictionary or something like that. So what you would do in the repr method though is just going to be you would return and then you would go just double check that I did that correctly. Then we would just return the string form of self. So basically what this is saying is whenever it's repeated multiple times, I'm just going to do what I usually do and return the string, which goes back to this function, and it just returns the nice version. So if we run that again, now it tells us that we have two things in there, and it displays them all in our very nice format. Does that kind of make sense why that works? It's a little bit new and a little bit confusing, and I'll send out some resources via Slack, but does why I had to do what I just did make sense? Any questions about this? Or anything else that we talked about today? Okay, so if there aren't any questions about this right now, pull up. I want to pull up. Where are you? Homework. All right, let's go over today's homework problems. So we have 3 challenges. Get through as much of them as you can in your groups. I'll send out group assignments in just about 5 minutes. So first one is app users 2. And screen share this. Okay, that's weird. Let me retry sharing this. Okay, so first homework problem is app users 2. So yesterday, I presume you guys made a user class called app users. Now what you need to do is do something similar to what we did today and add in some methods and some instance properties and some variables. So yeah, again, that's something that you guys will work on in groups. If you have questions or want to review anything, feel free to shoot me or Hader a message. We're both here today. The second thing that we're going to do is the credit check problem, which is basically a check summing algorithm to check credit card numbers. It has a couple of things that we need to do in order to make sure that credit card numbers are valid, and just check that it's valid according to our algorithm. And then our goal is to write a program that implements this algorithm to validate a credit card. And if we double check the folders here, there are some spec files that give us the inputs in string form. So keep that in mind for the credit card problem. These are being input as strings, not regular numbers. So make sure to keep that in mind. And the last homework problem for today is anagrams, which is pretty fun, where you're going to take in 2 strings and basically see if they can be shuffled around to match each other somehow. How you tackle this is up to you. There are a lot of fun ways to solve it, so I encourage you to think about it carefully. Pseudocode for all 3 of these is your best friend. So once you start looking at the problem in your small groups, talk to each other, find a plan, find a roadmap to solve these problems, pseudocode it out, write down some comments, then get to coding, and it'll be a lot easier. Does anyone have any questions before I end the lecture portion for tonight?
Just really quick for the anagram challenge, the examples show all the strings have the same length. Shall we assume that's the case? Should we do the code based on that?
You could if you wanted to. You don't have to, but you could.
Okay, so it could be that the strings have different lengths and just solve.
Correct.
Okay.
Yep. That shouldn't have. Oh, if you solve the problem one way, that shouldn't have any bearing on it. But if you do it other ways, it might. So it's up to you if you want to consider that or not.
All right.
But if you do the bonus, you definitely have to.
Yeah. Okay.
Any other questions? If not, so it is now 7:56. Class tonight is going to end around 9:45, same time as usual. So why don't we go in breakouts for, let's say, about the next hour and 35 minutes or so. I'll send out the random pairs in just a couple of minutes. So feel free to take a few minutes to grab a drink, walk around. And if you guys have any questions, feel free to, again, let me or Hader know either in Slack, in Zoom, and we will hop over. So best of luck, and we'll come around and check in on you guys every so often.